machine WOM and has been associated with the same from past 9 years. He has done masters in engineering drawing. He also has great experience in designing and development of surface mudlines, subsea wellheads and trees. With this brief yet impactful introduction, on behalf of IIDC student chapter, I welcome Mr. Siddheshwar sir. Before we start the session, I would request everyone to maintain the decorum of the session and to make sure their mics are muted during the session in order to avoid unnecessary disturbances. Participation certificate will be provided to those who will be with us till the end of the session. Before handing over to Siddheshwar sir, I also welcome Kunal Howal sir for coordinating with IIDC and making this event possible. Before any further ado, handing over to Mr. Siddheshwar sir to begin with the session. Over to you, sir.
Thank you. Thank you for this brief introduction, and thanks for hope my camera is visible.
Yes, sir.
Yeah. Thanks for inviting me to this session, and it's really great being in a class after long years, though it is a virtual, but feeling good that I'm in a class with the students. So we'll straightforward jump to the presentation. Let me share that. Let me know if you are able to see the screen.
Yes, sir, it is visible.
Okay. Today we will go through this. What we have developed from the company is the compact wellhead. So I presume here the from this the background of your college that you are aware of the different casings and all that which goes beneath the surface, and by this assumption, I will jump on this presentation of the compact wellhead. In between, if you have any clarifications needed, you can always stop me, or you can discuss at the end of this presentation. Okay. To Before we begin the presentation, it is a standard practice we follow is being in a oil and gas industry is the safety moment. You guys are aware that the oil and gas industry is quite critical field where the production fluid, which is the kind of gold, is produced, but it has its own safety and the concerns also. So we always follow a safety moment. If you are able to see the screen, it is the rusty lifting gear. One of the scenario is presented. The first picture is shows as unsafe condition where a heavy load is lifted by the crane with the help of chains, and the rivets which are fixed to the frame is kind of rusty. So first of all, it is an unsafe condition. Second act is walking below the suspended loading. It is another unsafe condition. If you come across that if the slings get snapped or break, the load can fall down, which, and if you are lucky, it's a near miss for you. And if you are unlucky, it's an accident, can be a fatal or permanent disability. Okay, and this safety moment is quite eventual in throughout our presentation. You will come across that in as we go through the slides. Another point is quality, which we need to maintain at every level, like during the manufacturing or during the installation or during the operations. So think zero defects. is, if you see this picture here, the quality is not maintained. If you could see closely, the slides doesn't have one of the hole drilled, and that's why that cannot be fixed to the wall. So this is simple quality moment, but we come across many of such during the work, and we need to take action, appropriate action every stage to get the quality in control. So it applies to you guys too in the colleges, like how the outputs you are producing and whether it is has this quality inbuilt in that. Agenda, what we will be covering in today's presentation, what is a wellhead and tree system, what standards we follow to design a wellhead and tree system, the wellheads and its parts. We will go through brief installation of the current wellhead system, which is we call as a conventional system. Then we will go through this new technology requirement, why these new technologies are coming in, and that is like the compact wellhead. We will go through the installation of compact wellhead system, and we will do a time analysis how the compact wellhead or the current technology is not worth and why we should be shifting to the new technologies like compact wellhead. And we will follow with the questions if you have any. What is a wellhead and tree system? Before we jump in, I would like to know, is this covered in your syllabus, the wellhead and tree system? At least brief?
Yes, sir.
Okay, that's good. So a wellhead, it is all the standard definitions taken from the international standards. Wellhead, it's all permanent equipment between the uppermost portion of your surface casing and the tubing head adapter. Okay, so what all these casings which are run in the ground, and every equipment which is connected to the surface of that or to the uppermost end is called the wellhead system. A tree, so it is a pressure containing part with three end connectors. Two openings opposite one another form the run portion of the T, and one opening is at 90° to the line of the run. Now when I'm talking about, just see my cursor. Okay, so this is the tree portion what we are referring to. So we have three openings. This is the vertical run, this is the horizontal run. Okay, and these are at 90° to each other. So if a wellhead and tree system can be categorized, it can be done in three ways. The surface wellhead system, which will be installed on the surface. A mudline wellhead system, which is kind of semi-subsea, where the water depths are quite shallow. And a subsea wellhead system, which is kind of a deep sea. So it is a subsea completely. So we will be using a FPSO or the subsea rigs to install this. So particularly in this presentation, we will be covering the surface wellhead system only. Okay. Standards, what we follow. So these are kind of the guidelines we have, and we have to adhere to these standards completely to supply these wellhead and equipments. So the main is API 6A, which is for the specification for wellhead and tree equipment. 16C for the chokes and kiln equipment. 16A for the drill through equipment. So what does it mean, drill through? So once you install these equipments, you can drill through these equipments. 6D is the specification for the walls. 20E is for the steel bolting or the fasteners we use in the equipment. 5CT is the casings and tubings. 5B is the threadings, gauging and inspection of the casing, tubings and line pipe threads. So casings and tubing. So 5CT and 5B goes in hand. The quality system what we follow is API Q12167, and there is ISO 15156-3 or NACE, National Association of Corrosion Engineers, MR0175. So all these international standards, why these are in place? it is to have the interchangeability between the different suppliers. So if an operator has to take the equipments from different vendors, he can do so. Only thing, they should be following all these standards. So they can use different vendor parts and they can assemble it and put it on the well. So system requirements. Now we will go into the design part of this, how we design it or what parameters we consider during the wellhead entry assembly. There are major four parameters we consider is the product. First, to start with, is the PSL level, or what we call is the product specification level. So there are different 1, 2, 3, 3G, 4. Okay, how it depends is the rated pressure of the well, at what pressure you will be producing it, what are the produced fluids, whether it is a liquid or a gas or a mixture of it, and what are the NACE requirements. So how much corrosive is that fluid? Okay, so all that guidelines, if you see this chart, it will guide us to select the proper PSL level. Okay, and this is even the operator or the who is going to drill the well, or you guys can do that. That how is the produced fluid, what are the pressures, and from that you can always select the PSL. Material class. So once we define the material class, based on that we have to and there are again guidelines, whether it is a general service or a source service. Source service means your produced fluid, whether it has the hydrogen sulfide in it and the CO2, the carbon dioxide. Okay, so these parameters will affect the life of the component which we are designing. Okay, the H2S, how it will affect, it can lead to the hydrogen sulfide cracking or sulfide stress cracking. Okay, so that is very critical from our design point of view, and the guidance is this table which defines whether it is a source service or a general service. In source service there is H2S content, in general service there is no H2S content. And there is also the parameter, the CO2, which will affect the design. There are the partial pressures of CO2 in the produced fluid or injected fluid. Both can affect the design. Okay, so on the left hand side, I have listed down all that, the composition of injected fluid, pH of water phase and exposure to salt water, production rates, because that will lead to the erosion of the part, and the concentration of acidizing solutions. So if we, before we design, we take these parameters from our customer to select the appropriate material, which will be suitable for the entire life. Temperatures. So the produced fluid which you are producing will have a temperature defined. In some cases, it is extremely high, and in some cases, the outside temperatures will be less. So here, if you see the temperature rating table, there are defined from K to V, and additional is X and Y. So if you see this minimum and maximum temperatures defined in that table 2, it gives minus 60 to 82 centigrade. So what does it mean? Minus 60 is the outside weather temperature or the atmospheric temperature, whereas this max defines the internal produced temperature, which is kind of first K, if you consider it is 82 degrees centigrade. So there is a mix of this also. My component can be between K to V. Correct. So if I'm installing my equipment somewhere in the north, Norway or some North Sea area where the temperatures are quite less, which are ranging minus 60s. So that equipment should be suitable for that. And the produced fluid is around 121 degrees centigrade. Then my design need to be suitable for that. So that range I need to design it, which customer probably most of the time customer specifies us. In some cases, the temperatures are extreme, like 350 degrees or 450 degrees. as given in the table G.1. Okay, so in these cases, what we have to do is we need to derate our equipments because those are subjected to higher temperatures. We need to derate the strength of the equipment to make sure it sustains the temperature, like temperature loads or the thermal loads, the expansions, everything, and the performance
Sir,
requirement. Yeah.
sir, what are the maximum temperature of wellhead? Like anywhere, matlab.
So maximum temperatures of the wellhead, if you see, those are going, in few cases, those go up to 650 °F. Okay, where there is a steam injection which is done from the outside. Okay, for the production of the, or increasing the production, or for the artificial lift system and all. So they inject the steam in the well, and those can go maximum to 650 °F in few cases.
Okay, sir.
Yeah. Now performance requirement. Now when we define or drill a well, ideally the well life is 20 to 25 years. Okay. So when we are designing the equipment, how we confirm that these equipments are suitable for that much life. So we do a performance test or a fatigue test on the equipment, where the equipments are subjected to drastic temperature variations from minus to maximum, okay, to minimum to maximum, and we cycle it. Okay, so as per API 6A Annex F, we do a PR2 qualification test, which is also called a fatigue test for the equipment. So what it gives the pressure and temperature cycles. These cycles are based on assumed number of operations a component is expected to see for an assumed design life of 20 to 25 years. So my equipment, if passes this performance requirement, I am rest assured that it will work for the 20 or 25 years of life without any issues. Yeah. So this is the standard rig structure you might have seen in the photos and all that. So if you see my cursor, this is the mast and this is the platform where the people will be standing, my rotary table, everything will be here. Okay, so where my wellhead will go in this? My wellhead will go below that platform in the cellar pit, which is getting highlighted. Okay, so if you see here, they have given a brief of that cellar pit where my wellhead and the BOP stack is there, but I have enlarged in this another picture. So this is my wellhead. This is the cellar pit, what we are looking below the platform, or the colored box. So my wellhead is sitting deep down in the cellar pit, and above that I'm installing the BOP stack. So this BOP stack is based on the customer, whether they're using the double dram BOP, annular BOP, different spools, spacer spools, or drilling spools. So this entire stack is mounted on my wellhead system before the drilling starts. Okay, and this is for the, in case of blowout, in some case of blowouts and all, the well is getting well can get secured. So this is the standard system, standard setup, which will be installed during the drilling of any wellhead or drilling of any well. Yeah. So my drilling is
Yes, sir.
completed. I am ready for the production. What it will change. So again, my cellar pit will be as is. My rig will go on, like it will move to the next slot where the drilling is going to happen. And then I will install my tree assembly over it for the production. Okay, so the tree we have seen the definition. It is a pressure equipment. It has bunch of walls, gate walls assembled in it to control the flow or just do the shutdown or the opening. The gate wall just act as open or close of the well. If you want to produce, open it and the production will start. So in this wellheads, when we are talking about a wellhead, what exactly it has? How many component it has? So it has a base plate or a standard landing ring to start with. It has a casing head or the tubing head or the casing spools or tubing spools or a compact wellhead body in it. Okay. It has the different casing hangers, tubing hangers. The hangers can be a mandrel type. If you see, this one is the mandrel hanger where my casings get threaded to my hanger. Okay, and this, the right side is the slip hanger. It has the slips in it, and instead of, if the customer wants to use the slip system, they can use this. So it is just the load. Once you apply the casing load on it, it will get energized and it holds the casing. What else it has? It has annular seal assemblies or the pack-up assemblies to seal the annulus once you install the casings and the hangers. It has the tubing head adapters or the different bonnet assemblies. It has the Christmas trees. It has gate walls assembled to it. It has different plugs for temporary suspensions. It can be a VR plug, kind of a wall removal plug, or a check wall. It can be a back pressure wall or a two-way check wall. It has different seals, fasteners, gaskets to protect the, again, to protect the pressures which are coming from the bottom. It has different kind of running tools like weir bushings. A weir bushing, like during the drilling phase, when you are running the drill bit into the wellhead, there is possibility that it can damage the wellhead internals. To protect that, you install the weir bushing or a bore protector. Okay, during only the drilling stage. Once the drilling is completed, you can take it out. Then you have the wash tools. So when you are drilling, you will be using lot of muds. There will be lot of debris and everything which will contaminate the wellhead internals. So it need to be washed from the surface. So we have the wash tools. There are, once you rig up the BOPs, the above the wellhead, it need to be tested to check the integrity that everything is perfect. You have the BOP test plugs to run it. So there are a couple of running tools we have or we supply along with the wellhead for the successful installation in the field. So we'll jump on the how it will get installed. So now we will go through the conventional wellhead, which are widely used still in the world. First is the installation of the casing head. So what we have, the first casing, you are able to see my screen, my cursor. So this casing is already installed or like cemented in the well. So we have drilled the well, we have run the casings, we have cemented it. Then what we do is we cut the casings to the required height and then we install this casing head above it. Now the design of this casing head can be different. Here the design shows as the slip type. So this was the landing ring or the base plate which we have seen in the previous slide. This is the slip system which is mounted below it. This is the slip system and this is the casing head, the gate walls. There are a couple of gaskets, VR plugs, everything in this. Okay, and this is mounted above the casings. What we do next, we will install the BOP stack above it for the drilling of the next section. Correct. So in this, the BOP has been rigged up above the casing head. What we do next, we will install the weir bushing and we start the drilling for the next section. After the drilling is completed, what we do is we will run the casings of the next section and we will install the slip hanger assembly. Now for doing that, what we have to do is we have to lift the BOP. Okay, so BOP will be lifted and it will be hanging above the personals which are going to work below it. Correct? So the BOP is just in the air, lifted by some slings and all, and people will be working here to install this casing hanger. And the casings are run, the installation is done, they will be installed the next flanges and all. They will install the next casing spool. So this is again under the suspended load. So once these casings and the casing spools are installed, the gaskets are installed, the BOP is nippled nippled up above this next casing spool. So you understand now, before like installation of this, BOP is in the air and people are working below the height. So the safety moment which we have seen in the first slide is a major concern in this conventional wellhead system. Installation of the next hanger and next spool. So once the next section of the drilling is completed, again the process is repeated. The BOP is lifted up and they will install the next hanger or the next casing spool with the gaskets and all that stuff. So again the process is getting repeated with the BOP in like hanging condition. Installation of the tubing hanger. So once the spool is installed, again BOP is lowered down and installed on the tubing spool. And after the drilling is completed, they will install the tubing hanger. Now, the tubing hanger here is a mandrel type hanger, and this tubing hanger is installed through the BOP. That's why the picture is a light color here as compared to the dark color BOP stack in the previous slide. I have purposefully changed the color here to understand that in the installation of the hanger, the BOP stack is not lifted and it is installed through the BOP stack. Okay, it is installed in the tubing spool and get locked. For the locking, we have some external locking screws which will be tightened against the tubing hanger, and then we do a pressure test to make sure the seals are intact. Now I have to do the tubing plug. Now when I have to go for a completion, I need to remove the tubing, I need to remove the BOP stack. How I will remove it? I cannot keep the well open because everything is drilled, everything is suspended. My tubing is suspended. I cannot keep the tubing open and remove any like BOP because there is chances of kick getting generated and the production fluid can come out. So it is a major safety concern. So we need to use the tubing plugs. So tubing plugs are installed inside the bore. Okay, inside the bore, because external there is annulus, there are annular seal assemblies already installed in the previous section. So whatever the pressures in the annulus is getting protected. Which is not protected is the main bore in the tubing hanger, and that's why we put the tubing plugs in the hanger to close that path, and then we remove the BOP stack. Once the BOP stack is removed, then we install the Christmas tree assembly and the tubing head adapter above it. Okay, after the installation of the adapter and the the Christmas tree assembly, we can take out that tubing plug because now we have the gate walls in place to, in case of any kick or the production coming out, we can always close these gate walls to stop the production. So there is now measures has been taken to control the production fluid. Correct? Any concern or any questions on this installation? Okay. So what are the takeaways? So we have gone through this brief installation and how it is done. So what are the main takeaways through this? So first one is unsafe act where person works under the suspended BOP loads during the installation. For every casing, so we have seen for every casing a new spool has been installed, which increases the total stack height of the system. Now connections, when we are adding a new spool, that connection need to be secured by using some gaskets. And if these gaskets are not proper, that might lead to a potential leak path in the future. So if we are adding many spools, that will get multiply the leak paths. Now, before even we rig up like the one we said, like we have to install the hangers, we need to lift the BOP. Now we need to lift the BOP in the sense we need to make sure that there is no kick going to get generated. So what they do, they cement it and they wait for cement to get hardened. Normally it process takes 18 to 24 hours for complete hardening of the cement, and people has to wait that much before they lift the BOP and install the hangers or the next spool. Correct. So it is very time consuming and in time consuming process of installation of the hanger and next spool. For every casing, like when we are drilling deeper and deeper, we need to use smaller sizes of casings. And then we need to use different slip hanger assemblies and annular seal assemblies for every section. So if you go from like if you are running 13 5-byte casing, then you are running the 9 5-byte casing, then you are running the 7-inch casing. So for every casing, there has to be a different annular seal assembly. These seal assemblies are not interchangeable. Okay, so you need to keep a stack of all these hangers with you during the drilling of the well. There are on the spools we use API flange connections. A flange connection is just a bolted connection where it has a through hole in the flange, and we use the stud nut connections to torque it, tighten these different flanges. Now for each flange, according to its size and pressure rating, has defined torque values on the studs and nuts. And to achieve that, we will be using some ratchet mechanism. Uh, and there will be minimum like 12 to 14 or 16 studs nuts in some cases, which will take minimum like 2 to 4 hours for per assembly to get tightened and tested. So again, this is a time consuming process. More, if you sum everything this, then you can understand how consuming like there is time consuming, particularly when we are talking about the conventional wellhead. It is going to take a lot of time to complete a well. And the table here shows the exact timing required for installation of only the wellhead part. So I'm not talking about here the cementing process. I'm not talking about the circulation process and all that. So I'm just talking about only related to the wellhead equipments which we supply and the timings which are recorded in the field. Okay. The consideration is given for one surface casing which starts with 9/5/8, the production casing which is 7-inch, and the tubing which is like tubing completion which is 4.5. And so start with cut and prep the 13 3/8 casing. It will roughly take around 1.5 hours or 90 minutes. Installation of the casing head, or it will take around 45 minutes. Make up the BOP riser, BOP stack around 120 minutes. Installation and retrieval of the bore protector before the drilling start around 20 minutes. After the drilling is completed, casings are run, it gets cemented, like you wait on cement for 20-24 hours, then you rig up, uh, install the 9/5 byte hanger and pack off. which is around 300 minutes. It is very time consuming process. Here the process has been a little reversed. Actually, we need to nipple down the BOP first, and then we will install the 9 5 hanger. So first nippling down the BOP, it is around 1 hour of time. Installation of the next casing spool around 90 minutes. Again, once everything is done, we will rig up the BOP and test the BOP, which is around 240 minutes. These are the actual numbers, correct? These are the actual numbers taken from the field for completing this well. Next, before the start of the next well, the bore protector is run around 20 minutes. Next, 7-inch hanger and pack of installation 300 minutes. So if you sum everything before we install the Christmas tree and complete the well, it is going to take around 2035 minutes or roughly 34 hours. Okay, roughly 34 hours to complete only for the wellhead installation. If you add up other parts, the cementing and all, the well can go for months. Okay. So now we will jump on why then new technology. These conventional systems are widely used. People are using in Middle East or in India, few places and all, though they are aware of that there are some safety concerns involved in this technology. Okay, but the oil and gas industry is mainly based on the proven technology, like whether your system is working fine, does it has the past history that it is working fine without any failure, then only the industry will uh, like allow the new systems to enter into their wells. So for the new technology, what are the parameters which we have concerned is the first of all safety, safety of the environment, safety of the personnel, and the product safety itself. Economy. Economy is again one of the major parameter the oil rig companies will consider because everyone is working for the money. So whatever the rig they are employing, the cheapest drilling rig spread cost per day or per 24 hours, and that is also for the land application if we consider, is ranges between USD 50,000 to $60,000. Okay, it is huge amount. So every hour of my installation service count. It's not only mine, all the vendors on which are working at the rig site, this every hour is counted because of the cost involved for the rig. Standardization, as we discussed, like the slip hangers in the conventional systems, we need to have the different slip hangers for different casing system. So that is a big problem for me because I need to buy a lot of inventory and keep with me. So how we can standardize those systems so that a common parts can be used in different casing system. And optimize the space, the shorter cellars. So when the operator has to dig the cellars, if the stack height is increasing, he has to dig deeper cellars, which again is a time as well as the cost consuming process. So how we can reduce this spacing, okay, by using the shorter cellars. So that's how these 4 parameters are considered in bringing up the new technology. We'll jump on now compact wellhead. This is just a picture of a compact wellhead system and the Christmas tree. So you can see the stack has many features like a single piece wellhead housing. Rather than different stacks, we have a single piece wellhead housing, the Christmas tree rather than separate gate walls. This is also a solid body Christmas tree with one body drilled with different wall positions. Now this wellhead system can be designed for 2 stages or 3 stages system. It can be compatible with different sizes of the BOP, can be like 9-inch BOP, 11-inch or 13 5/8 or 18 3/4. Pressure ratings, we can design it for 5K to 15K or even 20K design, 20K, 20,000 PSI pressures. Can we drill through this system? Yes, we can drill through this wellhead body. Once it is installed, we can always drill through it. The major factor, no wetting on cement. Like once we run the casing hanger into the well, there is no need of wet on cement. So you can straightforward do the cementing, and after the cementing, we can immediately start installing the slip hanger, installing the annular seal assemblies. How we can achieve it? In the hanger, we have provided some slots. So when you are doing the cementing, all the circulation will pass through the slots and it will come to the surface. So there is no need to wait on cement for installation of the annular seal assemblies. There are internal locking mechanism provided on the packoffs to avoid the drilling on the wellhead body. So there are no lockdown pins which will protrude or installed from outside. It has single bore profile and it can hang multiple casing strings without removing the BOP stack. This is one of the biggest advantage we have on the compact wellhead. So the BOP stack is never lifted once installed until the well is completed. It can be designed to 6A latest edition, can be designed for PSL 1 to 3G, temperature from 0 to 350 degree Fahrenheit, material from A to HH, and also it qualifies all the NEST requirement. Now the advantages we will see, the reduced potential leak path. If you see, these are the potential leak paths in the conventional wellhead system. And on the right hand side, there is only one leak path. So there is a reduction in the potential leak paths. We can't avoid it, but we can always reduce it. It saves the rig space. If you see the complete, now the casing program purposefully I am giving here because a wellhead system can be designed. It is all customized designs. Okay, so if you, it cannot be standardized. Like for this well, I have designed a wellhead. It can be used in another well. No, it's not like that because all the well parameters are different, though it is in the same area might be different, and the wellhead's requirement will be different. So each wellhead might be different from the other one. So that's why purposefully I have given a casing program here, starting with 13 3/8, which is the my conductor casing. 9 5/8 is my surface casing, 7-inch my production, and the 3.5 is the tubing hanger. So for that stack on the left hand side, my stack height is around 82.5 inches, which is around 2.1 meter. And on the right hand side, for the same casing program, my compact wellhead will be around 1.35 meter. So there is straightforward reduction of 56% in the total height. So that will, how it will help me? It will help me in saving the rig space or my cellars or digging up the cellars. Optimized design. As the arrow shows, these are the annular seal assemblies, which is getting installed after the installation of each casing hanger. So if you see the same casing, the annular pack of assemblies, I am using for two different casing hangers. So this is probably a production casing. This is might be a surface casing hanger or intermediate casing hanger. This is my production casing hanger. So both casing hangers are different. The bowl profiles are different, but my pack of assembly is same in both the cases. So how it will help me? It will help me in buying whatever the customer is buying the part. It will buy less inventory, and so that they can that their entire capex, the capital expenditure can get reduced. There is another new technology which is a WQ connector or we call it is a quick lock connector. So in the previous conventional wellheads, we were discussing about the flange connection, which will take minimum 2 to 4 hours for completion of one connection. How we have brought the new technology is with the help of quick connectors, which is shown here. And this is all proprietary designs, which it is superior alternative to APF flanges, offer faster makeup operation at the drilling site, designed to use standard API 6A ring gaskets. So when I'm talking about is the ring gasket, it is the interchangeability. Okay, so different vendor can have this API, this ring gaskets, which they have to follow the API. So I can install my adapter on the vendor's part in few cases if the designs are common. And this can, yeah. Okay, so any can be fitted to the drilling riser and BOP crossover adapter for efficient makeup and break. So many cases customer will be using drilling multiple wells on a particular site. So they want to drill their drilling rigs and the completion rigs might be different. So they want to do a batch drilling. So only one rig is coming and they are drilling two sections, and that rig is moving to the next location and drilling the next two sections. So in these cases, this quick connector helps a lot, because this connection will not take more than half an hour to complete to make and break the connection, as compared to 2 to 4 hours in case of flange connections. Okay, now we will go through this procedure for the compact wellhead installation. To start with, there is a landing of the compact wellhead. So again, we have the same scenario that my conductor casing is already cemented or grouted in the well, and I'm installing my compact wellhead above it. So I will come up with my running tool and install my wellhead assembly over the first casing in the ground. I will go ahead with installation of the BOP stack to start the next drilling. Okay, so once the BOP stack is installed, I will go ahead with BOP testing, where to make sure my BOP connections are perfect, my ramps are working, my annular BOP is working. So I do couple of tests by installing the BOP test plug. So this is BOP test plug, which is installed in the wellhead, and all the BOP testing is done against it. So this is the first and the last time I will be installing the BOP. After that, there will be no lifting until the drilling is completed. So here I'm installing the casing hanger through the BOP stack. Okay, there is a separate running tool. The hanger is a mandrel design with the fluted slots for passing of the cement or the circulating fluid. Okay, so I will install with the help of casing hanger running tool, install the casing hanger in the wellhead, do the cementing. I'm not going to wait. I will just remove my running tool to the surface, and I will go with the pack-up assembly or annular seal assembly through the BOP stack only. Okay. So I will install my annular seal assembly over the hanger. You see here, this is the internal locking mechanism, which we were discussing in couple of slides before. This assembly is installed above the hanger and it getting locked up from inside the wellhead. So there is nothing coming from outside which is going to lock the pack-up assembly in place. There are a couple of seals mounted above it to seal the annulus pressure between the two casings. Okay. Next, I will be drilling for the next section. I will be installing the hanger with the separate
Hello,
running
Siddheshawar
tool.
ji.
Yeah,
Sorry to cut you short. Can you please go back to the previous slide?
yeah.
So the snap ring which you are talking about, it's kind of a spring mechanism which gets like locked into a similar profile which we'll be running with the hanger.
Correct. So this snap ring, it's internally biased ring. So it will be in always collapsed condition. Okay. And
Okay,
once my pack-up assembly goes into the position, I will externally energize it. Okay. So I will energize it to open it, and open it. It is opening in what? It is opening in the groove provided on the wellhead. Okay. So this is
okay,
my
okay,
cursor is my wellhead, and this is my
mhm,
pack-up assembly, and the green color part is the lock ring.
okay, okay, understood. So it
Yeah.
needs to be energized from outside.
Yes. So this is the
Okay,
energizing ring. The cyan color part. This is my energizing ring. So I will push it from the surface or from the rig floor. I will push it down, and this guy will go down, and this will move it out. There is a spacing provided. The snap ring will go into the position and it will get locked.
okay. And in case this doesn't work or there is like some problem in it, so what's about the contingency of this part?
See what happens whenever we do, whenever we run, there are some dimensions we always measure. Like when we run the casing hanger into the position, we always measure because we are not lifting the BOP. People are working from the rig floor, which is around 10 to 12 meters of height, correct? So we have to make sure that everything is perfect before we run the next section. So when we are running the casing hanger, we always calculate what is the landing depth of that hanger into the wellhead, and that we measure it to the surface. There are a couple of markings we make on the landing joints, and that we make sure that it is matching as per our requirement. If it is not matching, we take the actions there itself before even we run the next section. Okay, so
Okay,
in this case, once the hanger is landed in position and we have made sure that it is in the correct depth, then only we go with the next, this annular seal assemblies. As the it is a stacked above the casing hanger, correct? The pack-up assembly is stacking above the casing hanger. So if my casing hanger is in the correct depth, this will be in the correct depth, and there will not be any problem in locking up that pack-up assembly.
and how will I get the confirmation that my hanger has set? Like on the drillometer, it will be confirmed, but what is the other parameter which through which I will be confirmed that my snap ring had been locked properly?
Okay, so once I lock the snap ring, I do a pull test. Okay, my for my installation of this annular seal assembly, there is a running tool. Where if you are able to see my cursor, there is a running tool for it, which is connected to the drill pipe or the landing joint to the surface. Correct. So once I lock my hanger, my pack-up assembly, I will tell the operator to pull it up. Okay, so they will lift, they will pull the entire string up. As my snap ring is locked, I will make sure that either a 50 kips of load or 20 kips, that is as per the design we define in our procedures, that at what load you can do this testing. Or sometimes customer comes back, they say, okay, my annulus pressure is this much. I want to do this test at that much load. We are okay unless and until the rig has the capability to do that testing. Okay. So what I
Okay,
have is
thank you.
the threaded connection. My running tool is connected with my pack-up assembly with some threads. Okay. So everything is connected. I can always do a pull test above it.
Okay,
Okay.
understood. Thank you. Thank you.
Yeah. So once my first section hanger and pack-up got installed, I will go with the next section drilling through the BOP stack in place. After the drilling is completed, I will run the same way the next casing hanger into the position, which will get stacked above my pack-up assembly. Then I will do the cementing of that casing hanger. Without removing the BOP, I will remove the casing hanger running tool to the surface, and I will go with the same pack-up assembly which was installed in the previous section. I will use the same pack-up assembly in the well, and I will install on that next hanger. There is no change in the pack-up assembly. Okay. The design is same. Again, we are doing the same thing. We will be installing it, and we will be energizing this green color lock ring into the wellhead groove. Then we are doing a pull test to make sure everything is fine. We will make sure the seals are intact by doing the pressure test between that. So there are a couple of test ports provided. If you could see in this snap, there is a test port provided on the body to test between these two seals. Okay, so in this case, we are sure that before even we start for the next section drilling, whether my seals are in good condition or not, if there are internal, like the annulus pressure is building, whether my seals can hold that pressure or not. So in compact wellhead during installation, after each and every component installation, there are a couple of checks we do before we jump on the next step. After all the casings are run, the final is the tubing hanger completion. So we will run through the same BOP stack, the tubing hanger assembly into the wellhead, which is landed on the pack-off which was set on the previous section. And it has the same locking profile. If you could see here, it also has the same snap ring, which will get energized from external means to get locked with the wellhead assembly. So there is nothing going from outside locking mechanism. So we are not drilling any holes on the wellhead body for locking or locking pins and all. So that will reduce my leak paths again. So once the tubing hanger is set, landed properly, then I will lift my BOP stack for installation of the tubing. With the BOP stack, I will again set the tubing plug in the hanger, and then I will nipple down the BOP and install the Christmas tree. Yes, so this completed the well. So in the entire process, if you see, we have not lifted the BOP a single time after installation. Can we do the time analysis now with the conventional and compact? You could see directly the reduction here. There is no nipple down and nipple up of the BOP in the compact system. So these figures are again taken from the previous slide for the comparison. The casings are same, casing program is same. These processes are same, and we have listed down this timing. Again, these are the actual timings from the field. Okay, so here there is no nippling down and nippling up of the BOP, which is straightforward going to save me this much time. Couple of this installation of the hangers, 9/5 hanger and the pack-up assembly in the previous system, it was taking around 300 minutes or around 5 hours of time. In my case, it is taking only 40 minutes, or even in some cases, it is less than that. Correct. So if you sum up these figures, it will boils down to only 9 hours or 540 minutes in case of compact system. So if you see the advantage of compact above the conventional system, there is a huge time saving of around 25 hours if you shift from conventional system to compact system. How does it save me? So if an operator is drilling around 50 wells as per the 50 wells in a year, straightforward, it will save him 50 rig working days. And one day we have seen it cost around 50 to 60K USD. So you think about the cost we are saving by just changing or shifting to compact system, apart from the safety which we are getting out of it. So it is a huge, huge saving for the operator. Now we will just sum up the delivered benefits of the compact system. It reduces the installation time, it reduces the leak path, saves the rig space considerably, reduces the well cost because we are installation time is getting reduced. It is kind of relatively the well cost will get reduced. It enhances the safety because we are getting the entire installation process and the drilling process through the BOP. Reduce the stack height, improves the accessibility of the components. There are minimum through wall penetrations. How it is versatile because using the same pack-up assembly for all the mandrel hangers. So it reduces the inventory for the customer and also provides the backup with the less inventory. If customer requests, an additional spool can be added to this to run like in between if the customer is drilling and they come across some scenarios where they want to run some liners and all. With this system, is it possible? Yes, it is possible. In few cases, we might need to add additional spools above the existing body, the wellhead body. Yeah. So this ends to the like this comes to the end of this presentation. Uh, we can always, if you have any questions, you can always start asking. This is open to all now.
You all can feel free to drop your questions in the chat box. I'll read it one by one. No questions?
Hello, Siddheshawar. This is Kunal.
Yeah, Kunal.
Thank you for this wonderful presentation. Just to share with everyone, I would like to know how many, like this is a pretty new system for the Indian territory, but can you explain or throw some light how many systems has been installed in India so far, and who are the operators this is using extensively in their field?
Okay, so as far as the compact wellhead system is concerned, we have the Indian customer as well as the international customer. So we have supplied these equipments all the way back from 2012 to one of our international customer is PTTEP, and they have installed around 48 sets of these compact wellhead system on their offshore rigs. Okay, so these has been installed for the offshore application also. Uh, Around 300 plus sets we have installed in India from last 4 years, and the customer is Vedanta Kane, and they are quite happy with the performance of that. So initially the Vedanta was using the conventional system extensively, but when they came across this technology and understood the importance of it, how much time it is saving, they are totally going with this compact system from the last now 7-8 years. Out of that, 300 sets has been installed and couple of more already in the line to getting installed.
Sir, we have a question from Jatin Nakrani. Is there any other connection rather than pin and box connection?
Pin and box. So you are talking about the casings?
Sir, we have to join the wellhead to the drilling pipe and casing. So there is other connection other than a pin in box.
Yes, there might be different. That's how in the slide I have shown first casing is the slip hanger, which we can install our wellhead on the first casing. We can use the quick lock connection for connecting my wellhead assembly to the casing. There can be slip designs, just slip on weld. The first casing, if you talk about the conductor casing and the surface casing, which are not that deep. So in those cases, the pressures are not that great. Those are very minimal, like 250 or max 500 psi. In that cases, we can always go with the slip-on design. So my landing ring will have just extra ID seals, which will get mounted on the landing ring, and it will get installed on my conductor casing, and I will rig up my wellhead above it. So there can be a quick lock connection, there can be a slip design, there can be a pin and box connection. So there are multiple options, and customer defines most of the time how much or what type of connection he wants to go with to save the rig time or according to their drilling plan.
Okay, sir. Understood, sir.
Sir, we have another question from Ashutosh Sharma. Is WOM Quick Lock API certified?
Yes, so this quick lock design is our proprietary design. So it is not an API design. Okay, API also gives the vendors or the manufacturers some flexibility to come up with their own design. Okay, apart from the listed by customer, listed by the API. So quick lock is one of the connection which we have developed, and it is API certified. We have done couple of validations on that, and yes, now it is API certified. So it matches. API certified means it matches the parameters of API defined torque values, API defined bending values, bending moment values. Maximum pressure rating of this connection is, as of now, what we have supplied is 15K, 15,000 psi.
Any other questions?
Just one more thing, Siddheshawar ji. For example, we are having the tubing hanger slots. So as you told, like these connections, like this wellhead would be like it would be only made for a particular well. So what the thing is, in case we are just for situational case, if we are running like we had a plan of running 4.5 inch tubing
Mm-hmm.
in a directional well, and in the later design we just changed, like during the planning or during the drilling stage, we just decided to run the 3.5 inch design, 3.5 inch tubing. So in that case, what is like I have to what are the things which I have to do for this wellhead? Like my wellhead would be having a 4.5 inch slot, or like 4.5 inch groove to hold my 4.5 inch hanger. And
Mm-hmm.
if I am running 3.5 inch hanger later, so what are the design change need to be done?
There are two things we can do is we can order a new hanger with 3.5 connection, or you can always use a crossover from 4.5 to 3.5. Okay, which is more cheaper. So to start with your drilling, you have considered the 4.5 will be required, and you ordered the wellhead equipment with 4.5 hanger. But as you go on start like drilling, and you come across some hurdles where you have to go take a decision that I need to run now 3.5 only. I can't go with 4.5. There is always a crossover can be used, because of what we are doing is we are talking about the internal ID of that hanger, not the external OD. Because my wellhead is designed for a external OD as well as internal ID. So my hanger can be designed, the same hanger I can use it or cut it to 278, I can cut it to 3.5, I can cut it to 4.5, or I can cut it to 5.5. Because I'm just changing the internal dimension. I'm not changing the external dimensions.
Okay, so you can use a crossover over there. So I'll be having
You can use a
three
crossover.
and a half. Okay, I'll be having the 3.5 inch string tilt surface. Then I'll be using a crossover and having my 4.5 inch connection itself.
Correct. Exactly.
Okay. Thank you.
Okay, so on this note, thank you, sir, for clearing all the doubts and delivering such an informative speech to our future engineers. I also thank all the participants for maintaining the decorum and making this event successful. Your certificates will be sent to you shortly. Thanks again to Mr. Kunal Howal for your support and hope to have same support ahead. We would also like to express our sincere gratitude to Sri Arun Karle sir for joining us today and for always being a mentor of IIDC student chapter. Thank you so much, sir, for joining us and gracing the event. I request you all to please turn on the video so that we can mark your attendance for your certificates.
Siddheshwar, you can stop sharing the slide.
Okay. Yeah.
Have you guys visited to WM facility
Yes, sir.
in past?
Few of us. Yes, sir.
When we came for the HSC conference at MIT today.
When was that?
Sir, last year, November 2021.
Okay.
Student of 20 student of
20 students
PDPU
from the PDPU came for
visited the WM.
Okay. Have you seen that twin compact wellhead system? Because it was there
Yes, sir.
that
Yes,
time.
sir.
Okay.
Yes, sir.
Good.
yes.
Sir,
So those who don't get the opportunity to visit, they are always welcome. You can coordinate with me or Siddheshwar, make a batch of few students. When they are in town in Pune region, you give us a call and we arrange a slot for you for another visit.
Yes, sir, definitely.
Yep.
thank you, sir. It is so nice of you, sir.
Okay, so with this, I would like to wind up today's session. Thank you. The meeting is now officially over.
Thank you, guys.
Thank you.
Thanks for
Thank you,
giving this
Siddheshwar.
opportunity.
Thank you,
you,
sir.
sir.
Have a
Yep.
great day, sir.
Thank you, sir.
Bye bye.
Thank you, sir.
Have a great time.
Bye bye.